Good morning to everyone and welcome to Santa's lesson on chapter 10.2 on two-step algebraic equations. In your MathLinks book, we're starting at 385. I think we started with question 5. Is that where we started? So question 5 says solve each equation model with algebra tiles. So the first question, 5a, says 4x minus 6 is equal to 6. So we talked about this a million times before. When you have a two-step algebraic equation, and what that means is you have both a coefficient, or a multiplier for the variable, and you have a plus-minus term that balances both sides. So Hayden, in this particular question, what is your constant in this particular equation? Negative 6. And in order to get rid of that, we learned that the opposite operations, so subtracting 6 and adding 6 are the opposite operations. So I'm going to do that to both sides. I'm going to keep them equal. And that's going to create 0 pairs here. So my next picture will be 4x equals 12. And once we get it to this, we really just eliminated our constant. So now we got to get rid of our coefficient. If I have 4x's equals 12, then if we divide those 4 x's into 4 groups, then each of those x's, I'm just going to use a solid line for this, each of those x's would be equal to, hold on, we're going to say 12? 3. So if you have 4 x's and you divide them into 4 piles, you get an x in each pile. If you do have 12 by 4, you get 3. And therefore, our solution is x equals 3. The next question we had to do was 6b. And 6b says, this says 7 minus 4x equals negative 9. So what this equation would be saying is 7 minus 4x, or a negative 4x, is equal to negative 9. That's actually what the equation says in this picture, right? So again, what's our constant here? Our constant is the plus-minus value on the side of the equation. So what would it be, Danny? It's a positive 7. Now, there are some people who, when they look at it from a number standpoint, think it's negative 7 because that negative sign is near the 7. And they're like, well, maybe it's a negative 7. No, when we draw it, we actually draw a positive 7. So it is a positive 7 coefficient. And when we want to get rid of that, we're going to add a negative 7 to this side, and that's going to get rid of it. And we're going to put a negative 7 on this side to keep it equal. That's going to create 0 pairs. And what I'm left with on this side, I'm not going to try and copy and paste again. That took too long last time. It's 7 or 4 negative x's. And over here, oh, that's way too many. That's 9, 15. That's 16 of them, isn't it? I'm going to get lazy. Just go 16 of those. So if 4 negative x's has a value of negative 6, then each of these negative x's has a weight of negative 4. So this actually says negative x is equal to negative 4. But we're not done yet, are we? Because we don't want to know what the value of negative x is. We want to know what the value of x is. That's what we're trying to solve for, x, not negative x. And in order to do that, you need to understand something important. That x by itself is actually equal to 1x. So even though we don't write a coefficient of 1, it exists. And the same thing is true with a negative x. It's actually a negative 1 multiplied by x. And the reason why that's important is because if you think about numbers and their opposite, if you take any number like the number 10, if you take the number 10 and you multiply it by negative 1, you get negative 10, right? So when you take a number and multiply it by negative 1, what kind of number do you get when you multiply by negative 1? You get its opposite, right? So essentially, if that's true, if you multiply any number by negative 1 and you get its opposite, then this actually means the opposite of x. Does that make sense to people? If you take any number, x, and you multiply it by negative 1, you will get its opposite. So since that is true, there are 2 ways for us to solve it. Now, if this is a negative 1 coefficient right here, how would I get rid of, let's say it's a 3 coefficient. How do I get rid of a 3 coefficient? I would divide both sides by 3. If it was a negative 10 coefficient, how would I get rid of it? I would divide both sides by negative 10. So here, this is a negative 1 coefficient. So what I'm going to do is I'm actually going to divide both sides by negative 1. And in doing so, I would find that x is equal to 4, right? If a negative x is equal to negative 4, or the opposite of x is negative 4, what is x? X is 4. From a pictorial standpoint, that just looks like this. It just means take your scale, do the opposite of each side, and you have your answer. If the negative x is equal to negative 4, then a positive x is equal to positive 4. Okay? Okay, on to question 7, and we'll do 8 at the same time. So in question 7 and 8, we're given four equations, A, B, C, and D. And the question says in 7, what's the first thing you should do to both sides? Now remember what we said in two-step equations, Dawson. The first thing you should always get rid of is either your constant or your coefficient. Do you remember which one it is? The positive or negative value, which is called your constant, right? So what we're going to do here is, all we're going to do is state what I'm going to do to both sides in number 1. So if I look at this, I want to get rid of that. So my first step, or 7a, is going to be, what am I going to do to both sides? I'm going to add 2 to both sides. And I'm going to choose BS. Appropriate. And then 8 says, what's the second thing you're going to do to both sides? So once that's gone, I want to get rid of this. And in order to do that, I'm going to divide both sides by 4. Divide 4 on both sides. Step 1 is to add 2 to both sides. Step 2 is divide both sides by 4. In question B, the first thing I want to get rid of is my constant. That's this 3 here, isn't it? Even though a lot of people think it's the minus 3, that 3, if I was to draw it, would be my constant, because it would look like, it would look like this. We kind of sometimes see it better if we draw it. So 3 and negative 3x equals negative 9. So if I drew it, I can see that that integer chip, whatever I would draw with integer chips, is my constant, and that's the 3. So the first thing I want to do is subtract 3 from both sides to get rid of that positive 3, or add a negative 3 to both sides. And once I do that, my 8b, the second thing I would do, I would divide both sides by negative 3, whatever the coefficient is. Because the coefficient of x is actually a negative 3x, and we can see that because when we draw it, we drew it as negative x's, not positive x's. Question C, first thing I would do is get rid of my constant, and my constant in C is negative 10. So for question C, the first thing I'm going to do is add 10 to both sides. And the second thing I'm going to do is I'm going to divide both sides by the coefficient of positive 2 on both sides. And finally, D, the last question, what am I going to do? I'm going to get rid of my constant of negative 1. I'm going to add 1 to both sides to get rid of that constant. And the second thing I'm going to do after that's done is I'm going to get rid of that negative 9 coefficient. I'm going to divide both sides by negative 9 on both sides. Okay, and now we have questions 9 and 10, which are solve these equations using opposite operations. So most of these questions are all grade 7 questions, and I'm going to highlight the only grade 8 questions. This is a grade 8 question, and that is it. And the only reason why that's a grade 8 question, can anyone tell me why that's the only one of the 8 questions that's grade 8? Danny? No. Allison? It's the only one out of all 8 questions that has a negative coefficient. And the reason why you didn't learn how to do that in grade 7 is because you did not know how to multiply or divide by negative numbers. And in order to isolate with opposite operation, we have to divide both sides by negative 7, a skill you didn't have in grade 7. Hold on, that's not true. I'm lying to you. Because if you have a negative value, okay, that's a lie. That appears to be the only one, but we'll see as we go through this whether or not some of these other ones are actually grade 8 questions as well. Let's look at the first one. So the first thing I'm going to do is subtract 6 from both sides. To get rid of my constant, I get 6r equals 12, because an 18 combined with a negative 6 is 12. Divide both sides by 6, and r equals 2. Is that a grade 7 or 8 question? It's grade 7 because there's no division or multiplication of negative numbers. In the next question, I'm going to use red here, I guess. Subtract 8 from both sides, get rid of your constant. 4m equals 4. Divide both sides by 4, and m equals 1. Again, a grade 7 question. Question C, my constant is 39, so I'm going to subtract 39 from both sides. 9g equals, what's that going to be, 36. Divide both sides by 9, and g equals 4. So far, all of those are grade 8 or grade 7. Nothing with division of negative numbers. And finally, our last question in question 9D, I'm going to add 139 to both sides. I get 102 equals 8f. And a lot of people got scared here because they're like, hold on, I must have screwed up somewhere. Because I'm going to divide both sides by 8 for a second. And 102 divided by 8, 102 divided by 8 is actually a decimal, 12.75. And that's okay because you never learned that in grade 7. So technically, what did I say that was 10.75? 12.75? 12.75. And it's okay to have values of variables that are decimals. You can even have irrational ones, I suppose. But for that's more of a grade 9. So that's really your first grade 8 question where you actually have a decimal value because you probably didn't have that in grade 7. As we move along to the next one, question 10 is a grade 8 question. And here's why. Even though your coefficient is positive, you have to divide both sides by 3. And now you need to know what negative 21 divided by a positive 3 is. That's not a grade 7 outcome, it's a grade 8 outcome. And what is a negative 21 divided by 3? Negative 7. So negative 7 is equal to k. There's our first. I'm going to highlight that in green too. Here's the first grade 8 algebra question, as is the next one. I'm going to subtract 1 from both sides to get rid of the constant. 28 is equal to negative 14n. Divide both sides by the coefficient, and n will equal negative 2. 28 divided by negative 14. And finally, your last one, your C, which is also, guess what? A grade 8 question. Doesn't look like it, but it is. Add 7 to both sides. 8x is equal to negative 24. Divide both sides by the coefficient, and in grade 8 you didn't know, in grade 7 you didn't know what this was, but now you do. X is equal to negative 3. And finally, your last one, believe it or not, is a grade 7 question. You add 12 to both sides. You get 4n is equal to 2. You might not have done this in grade 7, but it's not that hard. Divide both sides by the coefficient, and n will equal, what's 2 divided by 4? Yeah, if you think of that as a lowest term fraction, what would it be as a lowest term fraction? Instead of division, think of it as a fraction. What would it be? 1/2, and what's that as a decimal? 0.5. You don't always need to think of it as a division as much as you can think of it as a fraction. Perfect. All right, for question number 11, it asks us, show whether x is equal to negative 3. Now, there are actually 2 ways for us to show, because our answer only has to be yes or no. So what's the easiest way, probably, that would be the most comfortable, the less thinking, would be just to solve it, right? Solve each of these equations and see if the value of x is 3. That's one way to do it, using opposite operation. But a better way is to simply take your expression and substitute negative 3 into it. Now, if this, when I simplify it with BEDMAS, works out to be positive 25, then my answer is yes, x is negative 3. What's negative 8 times negative 3? Positive 24. And positive 24 take away 1 is 23. So is x negative 3? No, because if it was, it should equal 25, right? So our answer for A is no, it's not equal to 25. Again, take that same thing, substitute my x for negative 3, and see if this works out to be negative 24. Now remember, the question I'm going to ask myself is not what is negative 7 times negative 3, but what is 7 times negative 3? Negative 21, right? So my next line is 3, take away the product of 7 and negative 3, which is negative 21. Keep flip change. My answer is 24. Is the value of x negative 3? No, because that's a positive 24 and that's a negative 24. So the answer is no, x can't be negative 3 because they would be both the same if it was. Moving along to C, substitute negative 3 for my x. What's negative 10 times negative 3? Positive 30. And what's 30 take away 1? 29. So yes, in this particular equation, the value of x is negative 3. And finally, the last one, 6 times negative 3 plus 12 is negative 18 plus 12, which is negative 6. The answer is no, x is not negative 3. Does that make sense to everybody? How I did that? The other way you could have done it, just solved it using opposite operation and seen if x was it, but I wanted to show you this way because this is a good way to check your answers when you actually do an algebra question. Okay, our last 3 questions, 12, 13, and 14, are actually story problems. And we're going to is it just 12 and 13? We just did 12 and 13? Okay, my mistake. So 12 and 13 are story problems. So for these algebraic story problems, like we did in 10.1, we always said the first thing you're going to do when you're solving these story problems is do what? No, well, read it, of course. But the first thing you're going to write down is what? Define the variable. It should be in your notes from 10.1. So the first thing we're going to determine is what is the variable. Now, if we read our question, it's going to say S. So Matt is saving $750 to buy a clothes dryer. If he triples the amount of money he has saved so far, he will have $30 more than he needs. The situation can be modeled. Oh, it actually tells us this. Oh, I forgot this one. The situation can be modeled as 3S minus 30 equals 750, where S represents the amount of money he has saved so far. So S equals money saved so far. And then it actually goes ahead and gives you step 2, which is try and create an equation that matches this situation. So if we think about this equation, 3S minus 30 equals 750, why are we taking the amount of money he saved so far and multiplying it by 30? Why would we do that? Oh, sorry, multiply by 3, not 30. Why would we take the amount of money he saved so far and multiply it by 3 and then subtract 30 from it to equal 750? The reason for that is right here. If he triples the amount of money he has saved so far. So if S is the amount of money he saved so far, how do I express that algebraically, tripling it? So the reason why we're multiplying it by 3 is because he triples the amount of money he saved so far, right there. That's why the coefficient of 3 exists. But if he does that, he will have $30 more than he needs, because he needs 750 bucks. So if I put 3S equals 750, is that true? No, because if you triple his money, he will have $30 more than he needs. So right now, if I was thinking about a scale, he has saved more money than he needs. So how am I going to balance those two out? I have to add a constant of minus 30, because if 3S is $30 too much, the only way I can get that to be actually balanced with what he needs is to subtract 30. And now he has exactly the amount of money he needs. And that's why 3S minus 30 is equal to 750. Question 13 is your easiest story problem ever. It says if you're buying lunch at Sandwich Express, the cost of a sandwich is $4. And every topping you get on top of that is going to be $2 more. If you have $10, the equation used to determine how much extras you can get is 10 equals 2E plus 4, where E is the number of extras. So E is the number of extras. Number of extras. So why would I multiply the number of extras by 2? Why am I doing that? Why, instead of using E, why am I multiplying it by 2? Because each of those extras costs $2. So if you buy 5 extras, how much should it cost you? $10. That's why we multiply it by 2. The cost of each extra, or the cost of each E, is $2. Plus, why is the 4 there? The 4 is there because regardless of how many extras you buy, the cost of that sandwich is $4. So it does not change with the number of extras. That $4 is the price of the sandwich and nothing on it all the time. And to that, you will always add 2E, or 2 multiplied by the extras. And if the cost of this can be $10 exactly, the equation that models it is this. So if we solve this, we can isolate it, get rid of the cost of the sandwich. So just the cost of my extras can be $6. And probably right now you know how many extras we can buy. You know it's going to be 3. But we isolate it by dividing by 2. And the number of extras you can buy for $10 is you can have a sandwich with 3 extras on it.